right? Again, this is rotation about x, okay? But I'm going to assume mx is going to be positive in that direction. So AY is parallel to the geometric centroid. And the rules state that when it's parallel, you take it to the geometric centroid. Okay, so it's going to induce a clockwise direction. So AZ is equal to 300 multiplied by a distance of 12 inches. Okay, and then AY is going about the same direction. It's going to give me a AY, which is equal to 400. Multiply now. When the applied force is perpendicular to the centroid, you take it to the position of interest, which is AA, you multiply by 6. Okay? So this will be equal to 300 times 12, which is equal to 3600, plus by 400 times 6, which is 2400. So this will be equal to 3600 plus 2400 is equal to 6,000 pound inch. Let me do it again. Yep, 6,000 pound inch. So we know that our moment is 6,000. Okay. So the next thing, now I'm not going to find our second moment. So the second moment of area we know, okay, so we know that this only have one axis. So the general formula to apply, all right, is stress Z is equal to PZ over A, okay, plus minus MX over IXX multiplied by Y. Okay, IXX, wait, let me see, MX, the rotation, yep, okay, IXX, let me see, parallel, yep, IXX over Y, okay. So now, let me see, did I do this correctly, okay. So let's find IXX, I'm going to do it, okay, IXX, okay, so XX is a, XX is the axis of interest. So this is the width, and this is the what? This is the depth. Did I wait? Let me see. Do I do this correctly? Yeah. Okay. So the rotation about XX is going to rotate. So the width and depth. Yeah, it's correct. Okay. So IXX, the IXX. Somehow I'm having a brain fart over here. Okay, so IXX. So the width. Let me. It's too messy now. So IXX, IXX, IXX. Go on. How come I'm having a brain fart? XX. So this is the width, and this is the depth. Okay. So I'm going to take this two section twice. The width is equal to what? The width is equal to the width is in the vertical direction. The width is 0.5. The depth is, wait, 0.25. Okay, IXX. Then I have to do a plus. Okay, why I have to do a plus? Because the axis of interest is XX, so now it's twice 0.5 and then multiply by 0.25. Then the distance is equal to what? So 1.5 minus by 0.25 divided by 2 squared. Okay, so that is the rotation axis is in the x-axis. Yep. Okay, then I have to do the plus. Okay, the width is, now I'm doing the center part, 0.25. The depth is 3 minus by 0.5. And I don't need to take the centroid because the geometric centroid for the center part and the global part is the same. Okay, so let's see, do I have it right? So 2 times by 0.5 times by 0.25 power 3 divided by 12 is equal to 1.3021 times 10 to power of minus 3. Let me do it again. 0.25 power 3 times by 0.5 times by 2 divided by 12. Okay, so plus by 1.5 minus by 2.5 divided by 2 squared times by 2.5 times by 0.5 times by 2 is equal to 472.656 times 10 to the power minus 3. Let me do it again. 1.5 minus by 0.25 divided by 2 squared times by 0.25 times by 0.5 times by 2. 472.656. Okay, then plus by 0.25 the width multiplied 2.5 power 3 divided by 12 is equal to 325.521 times 10 to the power minus 3. Okay, so this will be equal to 1.30 to 1 power minus 3 plus by 472.656 power minus 3 plus by 325.5 to 1 power minus 3. So the second moment of area, I get 799.479 times 10 to the power minus 3 inches to the power 4. So the next thing I need to find is our cross-sectional area. So the cross-sectional area is twice of 0.5 multiplied by 0.25. Okay, twice 0.25 plus by 0.25 multiplied by 2.5. Okay, so twice multiplied by 0.5 multiplied by 0.25 plus by 0.25 multiplied by 2.5 is equal to, I get 0.875 inches squared. Let me do it again. 2 times 0.5 by 0.25 plus by 0.25 times by 2.5, 0.875. Right. So now we want to find what is happening at point A. Okay, so point A. So we know that at point A, the y is equal to 0. So stress Z at point A is equal to minus 300 divided by cross-sectional area, 0.875. So 300.875 is equal to 342.857 psi. Okay, I don't see that answer. 3 point, yeah. Now this question, I want you to calculate the shear. Okay, so that is our point A, because I have to do this without your knowing about shearing stress yet. Okay, and then at point B, where y is equal to what? At point B, the y distance is 1.5. And looking at how the structure is moving, right? We know that if this is a cross section, this will be in compression, this will be in tensile. So we have one that is minus, okay, one that is in compression. Let me check. Is our, yeah, okay, so moment about x tensile. Yep. So you have at point B, Okay, we will have minus 300 divided by 0.875 plus, because at point B is going to be at tension, and then the moment will be at 6,000 multiplied by a distance of 1.5 divided by 799.479 times 10 to the power minus 3. Okay, I don't know what the question is asking for. Let me see what is the question asking for. Oh, stresses at point B. Okay, so we do stresses at point B. So minus 300 divided by 0.875 is equal to minus 342.857. I'll do it again. 300 divided by 0.875 plus. Okay, so we have a plus by 6,000 times by 1.5 divided by 799.479 power minus 3. You get 11.257 times 10 to the power 3. So this is equal to minus 342.857 plus 11.257 power 3. You get 10.91 times 10 to the power 3 psi. Okay, so if we were to sketch the element, right? So if we were to sketch the element, so if this is the I-beam, right? So at point B, right? And we know that this is the fracture surface. If it's going to break this effect. So when we draw element, the element look like this. Okay, and then depending on how we label, we know that this is our X, this is our Y, and then this is our Z. We know that this is going to have a tensile of 10.914 times 10 to the power 3 psi. Okay, right, we know that, and we have no shear. Okay, we have no shear at this point. So now if we were to our go further, okay, now if we were to do this in a 3D Mohr circle, okay, so we know that in 3D Mohr circle, this is our normal stress, shearing stress clockwise, anti-clockwise. We know that over here, this is our point Z, and over here, these are both our point X and point Y. So this is our Z, this is our X, and this is our Y. Is because stress X is equal to stress Y is equal to 0. So now we draw our circle, and we know at this point is 10.914 times 10 to the power 3 psi. So the tau max, right, is equal to 10.914 times 10 to the power 3 divided by 2. Okay, so 10.914 power 3 divided by 2 is equal to 5.457 times 10 to the power 3 psi. Okay, so that is for this question. Okay, it's a very interesting question. You have to be careful down here. I was a bit lost down here. Okay, and I have to go back to fundamental. Where's our width, where's our depth? Okay, for this case, you have to use the parallel axis theorem. For this case, you don't need. Okay, that's all I have. Okay, anyone, any other questions before I let you go? And I'll see you tomorrow. Anyone? Any questions that you are not sure or you want me to go through again? Okay, so right at the end, right, you have constructed your element now down here, right? And you only know one stress Z value. So your stress Z value, so remember we draw this line, this is your what? This is your stress Z line, right? Stress X and stress Y are equal to 0, right? So you have 2 points, you only can draw one circle, yes or no? Okay, when that's the case, at this point, this is equal to 10.915, right? And the radius, the tau max is, because this is equal to 0, is 10.915. Actually, down here will be minus 0 divided by 2. And that's where you have 5.457. Andy, does that make sense to you?
And then for the rest of the question saying the principal stress, would that just be like the 2 points on both like the max and the min?
Say it again.
When it says determine the principal stress, is that just the max min points?
Stress min, it is.
Okay,
For this case, it happened to be one circle in 3D. Right? There are cases where you have 3 circles. You have to know where is your stress max. Like for this case, this will be your stress max. This will be your what? Stress min. This value over here, this is your stress min, means nothing. Does that make sense?
Makes sense.
Okay. Any other questions? Okay, if not, don't study too late. Sleep well. Tomorrow is in BSB. I think I put in the classroom name. It's BSB 106. I'll see you guys tomorrow then, okay?